loop thing while I talk about the robot, I guess, a little bit. Okay, I'm not like prepared with a real presentation, and I forget all the points. I added up my robot cost because I know Doug did that. So this one is about 370 bucks. I think is what I have in it. It could be done a little cheaper now. I'll kind of explain what's in the robot. I'm using an embed, which is a, I don't know, LPC 1768. It's a 32-bit ARM. And anyway, it's on a little 40-pin module, which is fun. Because then you can, in my case, I kind of like the wire wrap stuff, or pseudo wire wrap. So I've got a little breadboard from Tanner's, and 2 Pololu stepper motor boards. This is stepper motor driven, direct drive. Not a lot of torque, but a fairly fast robot, a simple design. Originally it was all 3D printed, but the motors got hot, and I print with PLA, and my robot kind of did something, you know, wasn't good. So I ended up redoing most, or a lot of the things with acrylic laser cut, which incidentally, Jose was saying he didn't build robots, but my laser is my first robot. I ripped the brain out of it and just recrafted a little bit to make my CNC laser. So really my CNC laser, I think it still has commands that it can turn, but I had to tell it it's now an XY machine. But you know, it still thinks it's a robot with differential drive. Anyway, so yeah, we got a stepper, and I made the wheels and everything. In fact, I have 3D printed stuff to hold the little O-ring tread. So there's an O-ring wheel there, but then the hub of the wheel I had to redo with a laser cut because it would, you know, it melted the whole thing. So let's see what else is on this robot. We got the embed, the stepper. Oh, I've got an IMU I'm not really using yet. This is a ST Micro 9-axis IMU. It's I2C interface. It was 35 bucks, but I'll call it 11 now because I think from China you can get a 10-degree of freedom. It's actually 9 degrees, and it has a barometric pressure sensor for 11 bucks shipped.
What is an IMU?
Oh yeah, yeah. So you can get your 3-axis gyro accelerometer and 3-axis magnetometer, and a barometric pressure thingy that can measure about, I don't know, 1 foot resolution or something. All for 11 bucks. I2C on a little module from China. So anyway, it's not. I think it's a single, probably maybe 2 chips. Anyway, so that's great. I put that on here because I was going to use that to detect when the robot got bumped into it.
Ron, what's the pressure detection on that? On the barometer? How many PSI?
Yeah, you'd ask me that. It's enough that it knows this much, whatever that pressure
like
is.
1,000?
They use them for altimeter.
Like 1,000 feet, or?
Well, it can do, yeah, thousands of feet. They use them in rockets. Yeah, that's where I learned about it.
For the drones, their range is 50 to 110 millipascals.
Yeah, look it up. It's, anyway, cool stuff.
I just happened to look at one yesterday.
So for communication on this robot, I have an Android interface that I wrote, and that I broke about a year ago, and I think it's coming back. I use a Bluetooth adapter, a little Bluetooth modem, and that talks 115 kbaud to the brain, whatever the embed. And also I've got an XB. I kind of like to use that for the PC interface. So those are my 2 radios. And then I've got, let's see, tabletop sensors. I use the little short range, sharp 10 centimeter sensors. They're available from Pololu, and probably the best way to get those is in a little module that has a little 3-pin connector, and they're about $6 a pop. And then for range, I use these 10 to 80 centimeter sharp IR sensors. Yes, they're noisy. Yes, I have 10 microfarad capacitors and 0.1 microfarad capacitors soldered right to the power leads to help suppress noise from them pulsing. So I've got 3 of those 10 to 80s. And then I've got a Pixie Cam, and the Pixie Cam I didn't use in the contest. In fact, the only thing that I ran in the contest was the tabletop with this. And I wasted time. What did I do? Oh, I got obsessed with, I wanted the thing to be able to tip, so I added a little kickstand where it could tip down, pick up the can, and then kick back. That way it could drive the can off the edge of the table, so I could do my perfect lineup of the cans. But anyway, I did that, and I did 2 cans, but Doug still won. So even though I've got a beautiful little robot, it didn't get me much, but it did give me a Beagle board, so that's fun to play with. Let's see, so for soccer, I've started playing with that, and right now what I've been doing with the Pixie Cam is running pretty simple algorithm, kind of like what Doug's talking about, where I do look at the angular field of view. And the other thing I've got going on here is I do a look down so that the vertical position in the frame tells me range along with the size of the can, because of the problem with odd things happening. So where the can is in the field of view vertically and the size gives me range information of the can that I'm looking at with the Pixie Cam. And something to mention about that, I would expect probably good things to come. It uses a dual core, I don't know, 200 and some megahertz processor, which for the limited resolution, they're using quarter VGA 320 by 240, as Doug mentioned. And with that kind of limited resolution, it's not so hard to do a lot of the imaging processing tasks. And I suspect that, I haven't looked at it in detail, but I would imagine the luminance information would be about double that, probably 640 by 480, not sure, and I may be lying about that, depending on how they digitize the information from the camera. But it is open source. The only problem is at the moment, or at the time I looked at it, it was a Kyle tool that you had to use, and that's what they had done all the software under Kyle, and I think that's $3,000 or something like that. But I would expect, or they were expecting and hopeful, that it would be, they'd have some sort of GCC release. So for this camera, I might be kind of hopeful that with that, you would see edge detection, not that difficult to do. I do it on my Android phone, and really a quicker way for most people is to get OpenCV. I looked at that, it's better than what I can do. I think they have a lot of native code stuff running, and their frame rates are greater than I can achieve. So, but anyway, that's kind of fun. I think I might still switch back to my Android phone just because I can do more with it. I'm interested in being able to do things like detecting moving objects and not just blobs. So that might push me out of the Pixie Cam, but I do like it because it's real high frame rate, 50 frames a second. And anyway, so that's a good plus. Anyway, that's it. Oh, so I'll show you. Something that I've worked on with this is really I started a simulation, and then I kind of got distracted by kind of working on the hardware and the real software. And I just thought I'd kind of show you that because I don't have like a PowerPoint presentation deal. Wait a minute, let's see if I can get this started. Unfortunately, I haven't tuned this simulation very well for older computers. At home, I have a 6-core machine, and this is only single core, and it runs, and also ridiculous amount of graphics acceleration on the desktop machine, 480 processors and all that. Let's see, so I'm just going to show you for fun what I've been fiddling with here. Okay, so here's the robot soccer field, I think. Is that the right size? I think it is. Okay, looks like the right size. Okay, so we can add some random cans. Let's see.
Is that truly random?
Yeah.
I would say next year, instead of arguing over who gets to put the cans up, we
there you
use
go.
your computer program.
Yeah, I do have some rule for this. so close to the walls. Okay, so now I'm going to try to bring up the soccer simulation. Now the problem with this is suck some resources on this machine, because what I'm doing is I actually have a camera mounted, a virtual camera mounted on my little OpenGL simulation robot. And so you're seeing what the OpenGL camera is actually requesting a scene render from the perspective of my little camera. Now this camera, I don't think I have a look down, come to think of it. I think I have this camera at the moment pointing straight ahead. And I can vary the, conveniently I don't have to buy lenses. I can change the, zoom, field view, whatever you call it. Okay, so let's see, and then we'll add our waypoints. I think I've got 4 waypoints. Unfortunately, they are animated, which is cool, but my frame rates are somewhat down right now. But those are the little waypoints, as you can see, are actually floating little cubes. I love computer graphics so much more than the real world, because sitting there, at first I made a little dot. It's like, why don't I have a floating cube, Anyway. Okay, so I'll start this and we'll see what happens. I may have to help it along a little bit. Let's see, because I think it may get stuck. We'll see. So there the robot's starting. Oh, the beams are its side-looking sensors. It's going to the first waypoint. Okay, now it sees the can. And believe me, this is as much a pain to get this simulation to work as it is. It's almost identical problems, but different to get this to work as the real thing. I mean, I've never had a simulation that wasn't this difficult or more difficult. But this is not using any dynamics, which that'll be next. I've done, in the past, I've done real physics simulations, and I think just for fun I want to throw that in because I like to do more fun things. So this is faked somewhat, but all the image processing you're seeing is working. In fact, I think that's a 320 by 240 image. So you're seeing almost identical what the Pixie Cam would do. And we'll see, let's see, what's its problem? Oh, I know I'm oversteering a little bit in my algorithm. I added a little fudge in there because I was having difficulty. So, and what it's doing once it's driving to the goal, I think I shut down and I go blind. But the other thing I think this will do is I think I've got it. I'll have to see if this is set up to do obstacle avoidance. I think I've got it set up to where I'll have it avoid other cans as it's driving to the goal. And let me just see. I think I can show you that. Let me look to see if I can drop my crumbs. Let's see. Now it's great to have the simulation because you can do stuff like add crumbs when it drives. Wait a minute. Oh, we also have the signs.
So, Ron, are the vectors, are the lines going out of the, are their magnitudes representative of the true range of the?
Yes, they should. Actually, we should see a spot. You know what? I'm lying. The forward sensor at the moment is operating. The side sensors, you'll see a little red dot show up. See as it's shining. Wait a minute. You'll see it in a sec. Hang on. Oh, let's see. Okay, here we got our robot crumbs. Okay, so now I've got the robot dropping crumbs. And this is kind of handy for diagnostic purposes. I can use that. Let's see if I can if it's going to do obstacle avoidance. Once it picks up that can, let's get some more cans. Once it gets a can, let's see, get a can. Come on. Oh, now it ticked it off. Let's see, I've done something to it. It's really well, there, we should be able to get it. There we go. Okay, now let's see if it avoids. Does it drive right through it? Wait a minute. We should get a chance to see it do obstacle avoidance. Unless. Nah, it didn't seem to do it, did it? Wait a minute, let me see if that's a checkbox on here. Oh, my turn gain needs to be turned up. Okay, so I've got a PID controller, well, PD controller on my turns. So in other words, as I drive and if I see an obstacle, we'll see if that starts to come into play. Let's see if we start to see it acting like it might actually care. It might start to freak out. I forget what the ideal gain was. We may have a situation where it locks onto a can and then freaks. Wait a minute. You'll get to see that I haven't finished the program because, let's see. And I don't have very good logic for like this situation, like, okay, we're looking at a can, try to ignore the other can. Okay, so what is it doing? It's freaking out. Let's try it. Let's follow the robot. Wait, I think I've got a camera on the robot. There we go. Yeah, so this forward sensor, the cyan, the magenta dot and the blue dot represent the range of the sensor. And when you'll see the spot on the can, that shows you where it detected the intersection with the can. See there? Whoop, there we go. But for some reason, it's now, oh, I know, it might have collected, did it collect 6 cans? How many does it have?
No, that's why.
23?
Yeah, 4.
4, okay. Well, I was going to tell you what, I'll just start it over.
Well, that might have been, that's a win, so that might have been where you stopped it. 4 would have been a win.
Well, I don't think I'm that clever. I don't know that rule. Let's see. Hang on, maybe we can start it over. Let's see.
What is this written in?
This is written in Delphi, which is using a library called GLC that handles all the low-level interface to OpenGL. So I don't have to do, I'm doing OpenGL code, but not, I'm getting some help from GLC. There's probably 50,000 lines of code they wrote. Let's see, okay, let's clear the cookies here and see if we can get hang on, let's see. Oh, I cleared the cans. Let's simplify our environment a little bit. Okay, now let's see if he goes back to the waypoint or if he's acting weird. And let me check my, boy, I don't have a label on that. That's interesting. I've got a turn gain and I can't remember what the ideal values, and I don't know what.
Oh,
that
just
is.
press it.
Yeah. Let's go back and throw in some more cans down. Let's restart the thing. Let's add cans.
Seems like it's avoiding all the cameras.
Yeah, so I was going with that one.
Okay, let's see. Okay. Yeah, that's weird.
It's a word.
Yeah, maybe it is.
It's a word not getting.
Okay, well, we won't. It finally got one. Okay. But then the thrill would have been to see if it. Okay. Anyway, you'll probably get the idea. And in fact, well, let's see. Oh, you know what? That's interesting. Well, those controls weren't updated. Let's just for fun. Let's. In fact, we ought to be able to see this. Okay, got that camera. I had to be there for.
So Ron, the idea of the 4 waypoints is to, otherwise, the idea is that from those locations you should be able to find all of the cans, or?
Well, yeah, or let's just say that was the first thing I came up with, and too busy. I just thought, well, I want to kind of drive the course, and so yeah, I wanted some way to return to or to circulate around the course, and that was it. But probably not that well thought out, because I think what happened is you get busy trying to do other things and trying to get all the things integrated into the thing. So anyway, but I think what this sort of stupid algorithm or thing that's happening is I had a problem where I would try to just calculate how much I needed to turn to head to my target. But then I ran into one of the problems I had is if I had 2 equal targets, I would oscillate. So I think what I did is I modified the algorithm to say, well, tell you what, let's just drive forward a little bit and then do it again. And then so we're moving forward. That way, I've at least moved, and I'm probably going to change the situation. But you know, you could sit down and think up, cool ideas like, okay, if I see a target, just let's go with it, sort of thing. But anyway, it's in the middle of the target.
What I used
Anyway.
Ron was with.
Yeah. Oh yeah. No, this I.
Why does
Right.
target was?
Right. Let me think. On this, I can't remember because it's been a month ago because I got sidetracked off into some other stuff. This. Early on, I've done different renditions of this can collection stuff. This first stuff I did was in like, I don't know, 2003 or 4. For that I would reject. I would look at the aspect ratio of the can. In fact, I even had the ability for that to notice that if I was getting equal aspect ratios, I would start to suspect like an edge-on can and not an upright can. But anyway, my computer might be at risk. Just thought I would show off that demo, and that's.
It seems like it's good at finding the center line to get back to the goal.
Yes. Now, one thing it is very good at in this simulation that I haven't incorporated, which is error odometry. This odometry is pretty spotless. It is simulated, but this robot is not slipping. The wheels are as close as the floating point realization is are perfect. But it is in fact doing true steps that mirror this robot's wheel steps and wheel step size. So in other words, the odometry is based on physically looking at left, right steps taken by the wheels, but in most cases, interesting. In most cases, in this case, although we should see it. The typical scenario for this robot initially was I would drive only straight to waypoints. So in other words, if you set it at some arbitrary XY position, what it would do, or let's just call it at the origin. So as if it's at the origin 0, 0 right now, and we need to go over here, what it would do is it would calculate the turn it needed to face that waypoint. So it would do the calculations, if I need to face a waypoint at 5,5 or whatever, I would do that 45-degree turn, execute that. And so that would mean ramping up and ramping down, the rotation on these stepper motors such that it, faced that angle. And of course, there might be some error in that based on the step size and so forth, which on these stepper motors is 200 counts per revolution, although I do use microstepping, but the microstepping's a little bit flaky because you never quite can depend on it, I think, especially if you start putting some torque or whatever, not an ideal situation for the motors where without feedback, I think, as you're between poles on the stepper, like if this is one step and this is the next step, you're interpolating the currents, and I think that's always kind of you don't really know. And I think that the fancy CNC machines I've noticed that use stepper motors will often have encoders on those suckers, and they'll use those to help increase the micro stepping resolution, so they really do know what the angle is on the motor. Not to be random. Anyway, that's my deal. If I get this looking better, I'll do another much shorter presentation. So
How long
that's it.
have you been programming that?
Oh, well, I started out with
Just a weekend?
yeah, that's a good question.
Looks like the one I did last week.
Yes. This simulation, different levels, but I think if I was going to recommend to somebody now, of course, I program most of my stuff in Delphi. It's Object Pascal. I use a tool that's now 12 years old, and it's ancient. But I think people that are going to start doing graphic simulation stuff, I'm sure there are game engines that would make, I looked at some of the game engines a little bit, thought about it. In fact, my biggest gripe was I didn't have cool audio. The thing I just wasted about 2 or 3 weeks on is doing audio synthesis, because I was real ticked that I didn't have, but you don't hear it here today, but next month you'll hear cool motor robot sounds, because I finally, just said to hell with it, I'll do my own sound effects and my own audio. But anyway, if you're interested in doing this 3D graphic stuff, I really recommend searching out some of the game engines. Now I know, I don't know to what extent Blender.
Yeah.
Blender has some game engine capability.
Yeah, no, it does. One has
And-
full Python support.
Okay.
You can do Blender no problem.
Okay, so yeah, he could knock this out in no time. But I definitely recommend having some support. My first attempts at OpenGL is I did all native low-level OpenGL code. It's kind of a pain. I mean, it's all right, but it's a little difficult. The tool I use here with Delphi, it kind of helps me at least kind of set up and work with objects that are fairly straightforward. I mean, they have a camera, and you define where you want the camera positioned and what angle you want it looking at, and it has a built-in timer, an animation timer that takes care of a lot of little hassles. In fact, today I would have been dead in the water, except I was able to get my compiler up and able to say, instead of render 30 frames a second or whatever it was I had it set at home, fixed, that's it. Today I said render at most that many frames a second, because this machine was falling behind, and doing these video renderings, those tend to suck more time. Oh, because then I was doing, so that picture there is a fake rendition of what the virtual camera on the robot sees, but then I'm applying all the same techniques as far as blob recognition there. In other words, that picture I'm turning into a bi-level, saying if I see orange in the picture, I turn those into ones and everything else zeros, and then I do the little searches and find those rectangular regions. So I mean, I have all the blob recognition code that the PixieCam does, so I got to do all the crud in there. But anyway, yeah, some of the game engine type stuff would be maybe the way to go, and there again, you'd have the ability to work with graphics primitives and things like that, and have a much, you wouldn't have to write a ton of code. So, for what it's worth.
You didn't cover my favorite part.
Oh,
The hand.
yeah, oh, I had my list of all the items, you know, the cost, embed, $50, XD, you know, and all this. Down at the bottom, doll hand was priceless. Yeah.
So is there like a Goodwill store with a little doll?
Yeah, that's yeah, my little secret. I ran out of money and I needed the hand, and so I went into a Goodwill store with my wire cutters.
Yeah,
And when no one was looking, they had a whole row of dolls. You know, one
You've
is
obviously
now-
never seen Ron's workshop. There's doll parts all over the
Oh,
place.
yeah.
Heads,
Anyway.
and you name it, it's there.
So you quite literally got it with a 5-finger discount.
Yeah, there you go. Maybe I'm lying. Okay. I'm on camera. Oh, now forever. I better make I did not steal from Goodwill. Yeah, no, I have quite a selection of dolls that were purchased when I had funds to do so. Anyway, that's my story. And I